Okay, so we're going to talk about carbohydrates. And carbohydrates, this is, they're very important. This is where your body gets its energy from. It helps to go through not just our body, but, plants use these carbohydrates in the, for photosynthesis. We use it for cellular respiration. So we're going to talk a little bit about carbohydrates. And these are things like sugars and starches and cellulose and glycogen, all found in different places throughout living organisms. Okay, very, very important. These carbohydrates are made of carbon, hydrogen, and oxygen, and they're in different ratios. Glucose in particular, and we're going to talk about it more when we talk about photosynthesis and cellular respiration. Okay, so glucose, which is C6H12O6. Okay, so that's 6 carbons, 12 hydrogens, and 6 oxygens. And if you look at our little equation here of CnH2nOn, that just means for whatever carbon and oxygen there is, however many number there are twice the amount of hydrogen. So if you look up at our glucose equation, our glucose formula, it's C6H12O6. Okay, and that follows along with our little equation, our rule there. Okay, so sugars, and that includes, starches, which starch will break down into sugars. Okay, so sugars, that's what gives us our immediate energy. That's why a lot of times you'll hear about athletes who carb load. They're really training hard and they're going to eat a lot of carbs, so they have a lot of energy to burn while they're doing these, very vigorous workouts. But they're made up of, these simple sugars, so glucose and fructose, all right, monosaccharides, okay. So these become some of the most, these are one of the most important, okay. So the monosaccharides, then you put these monosaccharides together, you link them up, and you're going to get a polysaccharide, okay. Things like starch. And you're going to find a lot of these starches in plant matter. Alright, so you eat that potato and it's going to break down into some more simple sugars from there. A lot of times you could take a just regular old saltine cracker, put it in your mouth, and if you just hold it there, as it breaks down, it's going to start to taste sweet as those polysaccharides break down into simpler sugars. Alright, so cellulose, plant material. This is what helps plants stay rigid and help stand upright. All right, it's kind of has a lot to do with fiber, right? When you're eating a lot of your vegetables, this is what those fibrous materials are made of. Glycogen. This is where animals store a lot of their unused energy. So if you eat too many carbs, you can't use all that energy. Then you're going to store it. And it's stored a lot of this is stored into liver, and then eventually it's converted into fat for long-term storage. So that glycogen is stored in the liver for short-term storage, and then eventually will turn into fat if you don't use that, which is going to bring us to our next macromolecule, which is a lipid. Okay, and lipids, these are fats, waxes, oils. All right, these are things that you're going to use in small amounts in your diet. All right, too much fat, of course, is bad for you, but they're also very good for you. We need fats. You can't go in without fat, because you have things like your cell membrane is made up these lipid bilayers. Okay, this stuff is very important as well. You gotta have those. So what about these? We hear a lot about saturated versus unsaturated fat. Saturated fat just basically means there are no double bonds between the carbons in saturated fat. Unsaturated fats, they have double bonds. So if you think about something as being saturated, if I put a sponge down into a bucket of water, it's going to be saturated because you pull it up out of there and it's dripping with excess water. It can't hold any more water. It's running out of the sponge. It's saturated. So when you have a saturated fat, there is no room for any extra bonds. It is all taken up with the hydrogen. Okay, bonds. There are no double bonds between the carbons. When you have an unsaturated fat, you have double bonds. When we can go back and review that video there about the carbon being able to bond to itself. So with an unsaturated fat, you may have one, you may have two double bonds, but with a polyunsaturated fat, you have many, many double bonds in there, okay? So, phospholipids, again, these are what's your cell membrane, the membrane structure, that's what they're made out of, is these phospholipids. So lipids are extremely important. You still need some of those lipids. And then things like cholesterol and testosterone. There's actually some cholesterol there in the cell membrane as well. These things all are very important. Testosterone, excuse me, and hormones and those kinds of things. Very important. All right, so you still need some lipids. So in the next video, we're going to talk some more about proteins and nucleic acids.